There's a box you can build for $4 that will protect every electronic device you own from an invisible threat. This threat is capable of destroying civilization in under 9 minutes, not slowing it down, not reducing the damage, eliminating it entirely. No circuit breakers will help, no surge protectors, no insurance policy. One event and every phone, every radio, every car, every medical device, every piece of grid infrastructure goes dark simultaneously, permanently. The threat is real, the government knows it, the military prepares for it. And yet, no agency has told citizens how to build a simple, century-old protection device that costs less than a fast food meal. In 1836, British scientist Michael Faraday discovered that a simple metal enclosure blocks all electromagnetic fields from penetrating its interior. Completely. The physics is absolute, no exceptions. The United States military has been building Faraday-protected facilities since the 1960s. Every nuclear command bunker, every government shelter, every classified communications vault is wrapped in Faraday shielding as a baseline requirement. They built it for themselves. They never told you to build it for your family. This is the story of the Faraday cage, the oldest electromagnetic shield in recorded science. The device that could preserve your ability to navigate and survive after the event that no one in power wants to discuss publicly. Welcome to Fixvival. If this knowledge matters to you, the subscribe button and the bell help it reach the people who need it. Here we open the vaults the industry locked shut. Now let me take you back to where this all begins. The year is 1836. London is the center of the industrial world, and a self-educated son of a blacksmith named Michael Faraday is conducting experiments. Faraday had no formal university education. He taught himself chemistry by reading books he borrowed while working as a bookbinder's apprentice. By sheer intellectual force, he became one of the most important experimental scientists in history. On one afternoon in his laboratory, he made a discovery. Faraday lined a room with metal foil and stood inside it while high-voltage electrical discharges were generated on the outside. He used an electroscope to measure what happened inside the room. The needle did not move. Not a flicker, not a tremor. The electromagnetic field crackling violently just inches away registered as absolute zero inside. Faraday had discovered electrostatic shielding. Fast forward to September 1st, 1859. The largest solar storm in recorded history strikes the Earth, known today as the Carrington event. Telegraph systems across North America and Europe spontaneously burst into flames. Operators reported receiving electric shocks from their equipment. Telegraph wires were the longest conductive infrastructure on the planet, perfectly positioned to act as antennas capturing every volt of induced energy. In 2026, those wires have been replaced by something infinitely more vulnerable, a continental grid and billions of semiconductor-based electronic devices. A Carrington-scale event today would cause trillions in damage. Recovery could take 4 to 10 years without a functioning electrical grid. Faraday's metal box, built from spare foil in 1836, remains the most effective and affordable protection against that exact scenario. The physics was already there, waiting in the nature of metal and charge. Now let me show you exactly why it works. The science behind the Faraday cage is one of the cleanest, most elegant demonstrations of physics in existence. There are no edge cases, no conditions, no exceptions once the design is correct. Here's what you need to understand. Electromagnetic fields, whether from a solar storm, a nuclear detonation at high altitude, or a directed energy weapon, travel as waves. Those waves induce electrical current in conductive materials they contact. That induced current is what destroys electronics. It is not the field itself that burns out a circuit board. It is the voltage surge that the field causes to flow through every piece of metal connected to that board. When an electromagnetic wave strikes a conductive surface, something remarkable happens. The free electrons in the metal instantly redistribute themselves. This redistribution creates an opposing field that exactly cancels the incoming wave inside the conductor. The electrons are doing the work of stopping the field at the surface before it ever penetrates to the interior. This is called the skin effect. The electromagnetic energy is absorbed and redistributed within the outermost layer of the metal. The key word is continuous. The conductive surface must be continuous, with no gaps larger than the wavelength of the incoming field. For the frequencies produced by a geomagnetic storm or a solar coronal mass ejection, gaps of a few millimeters are still small enough. For higher frequency directed energy, you need tighter mesh or solid sheet. This is also why a standard aluminum mesh or a metal garbage can with a tight-fitting lid can provide meaningful protection. The voltage produced by a Carrington-scale geomagnetic storm travels primarily through connected conductive infrastructure like the power grid. Electronics inside a Faraday enclosure that is not connected to external infrastructure will see none of that induced voltage. They survive intact. A nuclear electromagnetic pulse, known as HEMP, works on a slightly different principle involving 3 distinct phases. The E1 component is extremely fast, rising in nanoseconds, and damages semiconductor devices directly. The E3 component behaves almost identically to a geomagnetic storm and damages grid infrastructure. The same Faraday enclosure that protects against a solar event also attenuates the E1 pulse significantly. Protection depends on the conductivity of the material, the continuity of the seams, and whether the devices are connected to wires. This is documented in publicly available military standards, specifically MIL STD 461 and 464, governing electromagnetic compatibility. The physics has been known since 1836, and yet the average household has no Faraday protection for its critical electronics. Now let me tell you why. Here is where the story takes a turn that should make you genuinely uncomfortable. The global consumer electronics industry generates over $1.1 trillion in annual revenue. Every smartphone, every laptop, every smart appliance, every vehicle with an onboard computer represents a device with a finite lifespan designed to be replaced. The replacement cycle drives the entire economic model. Now think carefully about what a widespread Faraday cage adoption culture would mean for that model. If the average household kept backup electronics, a spare phone, a backup radio, all protected inside Faraday enclosures, those devices would survive an EMP event intact. The replacement cycle the industry depends on would be disrupted not by the event, but by the preparation. More directly, a culture of electromagnetic preparedness forces the electronics industry to confront a conversation it has actively avoided. If consumers understand that their $200 smartphone can be rendered non-functional by a natural event, they begin asking why the manufacturer did not include hardening. Why the entire product line is built with zero consideration for the threat that every military contractor accounts for as a baseline requirement. The consumer electronics industry has no answer to that question that does not cost them money. Beyond the hardware manufacturers, there's a second layer of institutional resistance. Emergency preparedness is a government responsibility in the public mind. FEMA, DHS, and state emergency management agencies set the national conversation about what citizens should do to prepare for disasters. The official guidance includes water storage, food supply, and first aid kits. Not one official checklist includes Faraday cage construction. Not one government public awareness campaign has ever included instructions for protecting critical electronics from electromagnetic events. And yet, those same agencies have spent hundreds of millions building Faraday-protected facilities for continuity of government operations. They built the protection for the institutions. They never shared the instructions with the individuals. The economics of emergency preparedness also create perverse incentives. A well-prepared population is a less dependent population. Dependency drives federal funding requests, disaster relief budgets, and the entire apparatus of post-event government response. A $4 Faraday cage built in an afternoon by any citizen with basic tools does not require a federal response program or a FEMA contractor. And for that reason alone, no one in the institutional structure of emergency management has ever made building one a public priority. The knowledge did not disappear. It simply moved to the margins, where institutional pressure does not reach. In 2003, the Congressional EMP Commission released an unclassified report concluding that a high-altitude electromagnetic pulse attack on the United States could collapse the national power grid and cause societal disruption on a scale unprecedented in modern history. The report was public. The findings were stark. The recommended civilian protective measures were nearly non-existent. A follow-up commission report in 2008 went further, describing specific vulnerabilities in grid infrastructure and the cascading failures from a major EMP event. The report was again public. Again, no civilian Faraday cage guidance followed. In 2017, the North American Electric Reliability Corporation published a grid resilience study acknowledging that geomagnetic disturbances represent a credible threat. The document outlined protective measures for utilities. It said nothing about individual preparation. Meanwhile, in online communities and amateur radio clubs and off-grid homesteader forums, and in the quiet corners of hardware stores, a different conversation has been happening for decades. Ham radio operators have understood Faraday protection since the Cold War era. Military veterans who worked in communications know exactly what a shielded enclosure does and why it matters. Preppers and survivalists have been building metal trash can Faraday cages and lining ammo boxes with aluminum foil for 20 years. The knowledge has never disappeared. It has been maintained by the people who understood the threat. In 2019, a team of electrical engineering students at the University of Texas conducted a study measuring the effectiveness of common DIY Faraday enclosures. A standard galvanized steel garbage can with a tight-fitting lid provided between 20 and 30 decibels of attenuation across relevant frequency ranges. A nested enclosure, one container inside another with an air gap, pushed protection well above 60 decibels. A 60 decibel attenuation reduces a 50,000 volt per meter EMP field to roughly 50 volts per meter. Most modern electronics can tolerate that. This is achievable with a $4 metal container and an hour of your time. Here is exactly what to build. This is the part they have never told you, so pay close attention. The most effective entry-level Faraday cage for civilian use is a galvanized steel garbage can with a tight-fitting metal lid. You can buy one at any hardware store for between $20 and $35. That is your outer shell. Line the inside of the can with a non-conductive layer. Cardboard works, heavy craft paper works, closed cell foam works best. The purpose of this lining is to prevent the electronics from making direct contact with the metal shell, preventing induced current. Cut the cardboard or foam to fit the bottom, sides, and underside of the lid. Tape all seams. The interior should be fully lined with no metal-to-device contact possible. For additional protection, wrap each individual device in a separate layer of aluminum foil before placing it inside the lined can. This creates a secondary Faraday layer. For critical devices, use a Ziploc bag before the foil wrap to protect against condensation. Press the lid firmly onto the can. If the lid fits loosely, wrap the seam with copper foil tape. The tape creates a continuous conductive seal at the junction between lid and body. That is your basic Faraday cage. Total cost between $25 and $40. What to store inside? A backup. AM/FM shortwave emergency radio is your most critical item. In a post-EMP scenario, radio is how you receive information from emergency broadcasting infrastructure. A battery-powered radio with a manual crank backup is ideal. A spare mobile phone with a charged backup battery bank. Even if cellular networks fail, it stores maps and offline apps. Keep the phone in airplane mode inside the cage. A USB power bank with at least 20,000 milliamp hours of capacity. It can charge phones and run LED lights. A backup GPS device with downloaded offline maps. Do not rely on phone GPS if cell towers are down. A dedicated GPS unit with preloaded terrain data is a separate critical tool. A solar charge controller and a small flexible solar panel folded and stored inside the cage. Post-event, this allows you to recharge your power bank from sunlight without grid power. A pair of handheld two-way radios for local communication. Store them with fresh batteries installed. The entire kit costs between $150 and $300. The Faraday cage that protects it costs $40 at most. For a more advanced setup, nest the steel garbage can inside a second, larger garbage can with an air gap. The air gap acts as a wave impedance discontinuity that dramatically improves attenuation at high frequencies. Line both cans. Use copper tape on both lid seams. This two-layer nested cage will protect against virtually any realistic EMP scenario. For vehicle electronics, a second smaller cage made from an ammunition can store backup ignition modules. Older vehicles, pre-1980 carbureted engines, are largely immune to EMP effects because they have minimal semiconductor components. If you have one in storage, protect its ignition coil and distributor cap in an ammo can cage just to be certain. The entire system requires no special tools, no electrical knowledge, no professional installation. 4 hours on a weekend afternoon and a single trip to a hardware store. This is what Michael Faraday discovered in 1836. This is what the United States military has been building for decades. This is what the average household has been denied the instruction to build for themselves. The 1859 Carrington event happened before the electrical grid existed. The damage was spectacular but survivable because the infrastructure of civilization was not yet built from components that electromagnetic pulses could destroy. The next one will be different. The solar cycle operates on an 11-year rhythm. Geomagnetic storms are not hypothetical futures. They are historical regularities. The sun does not negotiate with insurance actuaries or congressional budget committees. It operates on physics older than this planet. Michael Faraday was a blacksmith's son who taught himself science by reading borrowed books at night. He had no institutional backing when he lined that room with foil and stood inside it while electricity crackled on the outside. The answer he found was absolute. A continuous conductive shell stops electromagnetic fields. Completely. Without exceptions. Without upgrades. Without subscription fees. The laws of physics have not changed since 1836. The threat they protect against has not changed since the sun first flared. The solution has not changed since a self-educated man in a London laboratory proved it with spare materials and a careful mind. What changed was who was allowed to know about it. Some knowledge is hidden because people who benefit from your unpreparedness control the information. A $4 metal box, an afternoon of your time, devices that work the morning after the event that silences everything else. Faraday gave you the physics. The military confirmed it worked. The instructions were never classified. Now you remember. Subscribe and share. Next, we reveal why the construction industry stopped using fireproof materials after 1972 and why your walls are more vulnerable. The vault is open. The next door is already unlocked.